Now let's continue another interesting debugging in practice. The screen you are looking at is the software assembly instruction in the supervisor mode. In the supervisor mode, as you know, Linux kernel runs. So in this debugging practice, I'm going to run ECALL assembly instruction in the supervisor mode. And you're going to see what's going to happen from RISC-V perspective. But before we start this debugging practice, so let's understand the OpenSBI call. What is OpenSBI call? So behavior of the OpenSBI call is almost similar to system call. The system call can be invoked in the user mode to request service from supervisor mode. As you know, the system call number should be specified before running ECALL assembly instruction in the user mode. The OpenSBI call is acting just like the system call. If the supervisor mode wanted to request some sort of service from the machine mode, ECALL assembly instruction should be performed in the supervisor mode. After running ECALL assembly instruction, the privilege mode switched from supervisor mode to the machine mode. And another important thing you can observe is that the mCOS register. mCOS register will be updated to 9. So without further ado, let's continue this debugging practice. So I'm going to click this step button to run this assembly instruction. Here we go. So as you can see, those assembly instruction is to specify the value in the A0 to A7 register. This operation is performed to send the parameter argument before OpenSBI is performed. Now we are in the important moment. We are about to run ECALL assembly instruction. Let's see what's going to happen. So I'm going to click step button. So please pay attention to this window along with the value. So here we go. 1, 2, 3. As you can see, two things happen at the same time. First thing is the point counter moved to this function. It looked like a function, but it is a trap handler in OpenSBI. And another important thing is to remember is that the current privilege mode is machine mode. Please look at this. This icon shows you the current privilege mode is machine mode instead of the supervisor mode. So once ECALL assembly instruction runs in supervisor mode, the privilege mode switched at this moment. Now you are going to look at the value of the mCOS register. So for this, I will navigate menu from CPU. I'll select the parameter. Then I will move to the control and status register menu. From here, I will look at some of the important CSR register. So please look at this. Now, the mCOS register has 9. So 9 is indicating that this exception is caused by environment call from S mode. S mode means supervisor mode. So at this moment, I'm going to modify the value of mCOS register by double-clicking this icon. So please look at this. I will change the value of mCOS register. And then what I'm going to do is to revert the execution of assembly instruction. That instruction was ECALL assembly instruction. So for this, I will use this command. As you can see, this is r.undo command. There you go. As you can see, we back to the previous privilege mode. Now it is supervisor mode. We move back to the state before running ECALL assembly instruction. Now at this time, the machine cost register has 0 at this moment. Now let's see what's going to happen if I run ECALL assembly instruction. So at this moment, I will rearrange the position of each window. So please wait. Okay. So now, and it's about to run the ECALL assembly instruction again. So please look at the value of M cost register together with this icon and this icon. So here we go, 1, 2, 3. So as you can see, so M cost register is updated to 9. 9 means environment call from S mode. Now the privilege mode is machine mode, and the frame counter is moved to address of trap handler. The name of this handler is available in OpenSBI. Since OpenSBI is available, then it is used as open source project. You can look at the body of trap handler in OpenSBI. Now that we got to know that the 9 is the exception code for environment call from the supervisor mode, so we are going to perform another interesting debugging practice, is to modify the value inside the machine exception delegation register. Now let's this debugging practice we will continue in the next lecture.